Good morning, students. Welcome to Learning Hub, and today we are going to read chapter 1 of Science Class 9. So, the chapter is Matter in Our Surroundings. So, what do you mean by matter? Matter. What is matter? Like, yeah, just I hope you've read out the chapter, and for explanation, I'm here. So, for explanation, yeah. So, what is matter? So, we're gonna read its definition and understand and relate it to our daily surroundings and whatever we see in our daily life, right? So, basically, we're gonna read about its definition and characteristics, or it is written wrong. CHA, sorry, yeah, and then diffusion and its applications, and Brownian motion, states of matter, interconversion of three states of matter, like you know very well. States of matter, yeah. So you know very well there are three states of matter, that's solids, liquids, and gases. So we're gonna learn about how these change into when we have solid, then we convert into liquid and to gas also. Then evaporation and their physical quantities and SI units also. So we have here keynotes of chapter matter in our surroundings. So now let us learn what is matter. So what is matter? You might have seen, oh, what's the matter? You speak out these words, right? What's the matter now? So matter, that is something that kind of triggers you, right? So anything that occupies space and has mass is called matter. So like we are also matter, and like a table on which you're studying, the bed in which you lay, right? These all are matter because they occupy space, and they have mass also, right? Yeah. So these exist in the form of five basic elements, and you can say the Panch Tattva, and they are air, earth, fire, sky, and water. Yeah, these are the matter. For example, chair, bed, river, mountain, dog, tree, anything that exists on earth is called matter, right? Yeah. Um, let's take some example, like if you're going to any market, right? If you go to market, you see many items over there, and you see that little spaces, you know, left to walk. What is that? Yeah, little space left because they have occupied the area. Suppose we are going to a market. Suppose this is a place, or this is the shop you're going to, and suppose it's it's a furniture shop. Yeah, let's take furniture shop. You know very well that furniture covers almost the area of the shop, right? And they have go down also, but some don't have go down, and like you entered, right? Yeah. So suppose this almirah is kept here, and some things are kept here, right? And this is the main door of the shop, right? So this one also, right? So suppose the shop was of let's take 52 square kilometer, right? 52 square kilometer, right? Yeah. So how so in this area, you you've entered the shop, and in this area, suppose 45 square kilometer is covered by the materials of furniture, right? So what is the remaining one? Only 7 square kilometer. This is a area that is left for walking, like for you have entered the shop, and you see only 7 square kilometer area to walk in. That's not fair, right? So what are the furniture doing? What is the furniture doing over there? So those furniture are like occupying some space from 52 square kilometer, and left the space is 7 square. Don't go on measurements only, you just imagine whatever I'm saying, right? Yeah, so what did we learn here? That anything that occupies space, like you also, you're like you're sitting on chair, right? So chair is being occupied by you. Yeah. If you go in an aeroplane, right? So in the washroom we see that if we lock the washroom from in, we see that from outer side, if we see that it is written in this form, and it is written occupied, means something is someone is in. Yeah, someone has occupied, or someone has occupied the space, so you can't enter there, right? Yeah. And anything that occupies space and has mass, like something mass over there, right? Hmm. So five basic elements are air, earth, fire, sky, and water, right? Yeah, this how made you understand. So let us learn about some characteristics of matter, right? So matter. So you know very well. So let's take an example, right? Uh, I'll tell you my example. When I was too young, uh, like someone gave me a chocolate, right? Sorry, not chocolate. They gave me a paper, right? Someone gave me a paper. So what did I do? So they told me to tear it up. From which extent I could have torn it, right? So I tore it to smaller and smaller pieces. Like this one is a paper, and I tore it into two pieces, then four pieces, then six, right? Uh, like this, I've tore it to what extent I could. So after that, one question came in my mind. That was, from what extent can we tear something, or can we reduce something that it would be the like non-tearable form, right? This question came. So after reaching this class, I learned that that uh, that matter is made up of small particle. Everything in the world is made up of small particle. Even your chair, even your wood, everything is made up of small particles. So what are these small particles? What are these small? They should have some specific name for them, right? So what could be the name? Yeah, this is the one, atoms. Atoms, you might have heard this in 8th class also, right? So atoms are the smallest particles, right? That they're not even, we can't observe them with a naked eye, right? So these are only visible through electron microscope or microscope. Yeah, microscope. Yeah, very microscopic, right? So yeah, next is, yeah, the same that I told you now. These particles are too small to be observed with a naked eye, so we can't even, we can see the output, like the wood and chair made from the atoms, right? But we can't observe the atoms with our naked eye. We can observe only the output. That's chair and water, sorry, chair and wood. Yeah, but we can't observe the atoms because they're very small. If we the cell also, the basic building block of your body, right? Can you see? Yeah, you can see. But yeah, you can see your tissues in your hand. If you look at your hand, you will see many of the tissues coming together, right? Yeah, but you are only looking at the output, not the input that the cells are going on through, and what is being going on in your body. You don't know, but only, not practically do but yeah, you know. But yeah, let's come to the topic again. Yeah, so our next is, these particles are constantly moving. Sorry, it is written. Yeah, these particles are constantly moving. uh, these are constant. Do you see, if you look at your table, do you see any of the particles inside your table moving? No, you can't, because they're small. Yeah, it is so you can't see that, oh, atoms are also moving. You can't observe them, right? Because they're too small. You have to look into your microscope, and you find your microscope and then look at the table. Yeah, so fishy type thing. Yeah. So next is these particles have spaces between them. Particles of matter attract each other because of the force of attraction. Yeah. So force of attraction basically is higher in solids, because you see that tables, they are joined, they don't move from one place to another, so the atoms are tightly packed, right? So these also have spaces between them, but solids have very much, they're tightly packed, tightly, I mean they're just hugging and everyone, right? They're just not letting anyone to move out the way, right? Yeah. Next one is diffusion. So what is diffusion basically? So what is diffusion? Particles of matter intermix on their own with each other. They do so by carrying into the spaces between the particles. So when you see the particles of matter intermix on their own with each other, like they're mixing with each other. Diffusion, like the intermixing of particles of two different types of matter on their own is, suppose I've taken a beaker over here, please look here. Yeah, I've taken H2O, that's H2O, that's water, and if I add sugar in it, sugar is like this, if you microscope it, these are like sugar cubes, right? Sugar I've taken and I've put some sugar in it. So what would happen? What would happen in the beaker? The water would get so sweet, right? It would be so sweet. Why? Because of diffusion of solid and liquid, right? So solid was the sugar. Solid, what did we take as a solid? Sugar, right? And what did we take as a liquid? Water, right? Liquid was water. So when we had a beaker and we mixed up sugar cubes into it, these intermixed because of diffusion of water and sugar, liquid and solid. So diffusion is basically intermixing of different types of matter, right? Yeah. Let's get on to the next one. So we have here applications of diffusion. So what are the applications of, yeah, did this, yeah. So what are the application of diffusion? So you might have heard of I told you this one, that if dissolving a solid into a liquid, you can take potassium permanganate, but I have taken sugar. When a crystal of potassium permanganate is placed in a beaker of water, the water slowly turns purple on its own, even without stirring. So you know very well, by this process, what do you get it? uh, when you suppose, don't be so like deep and somewhat scientific. Let's take a home example. Suppose if you want to when you are painting something, right? When you paint something, you just like when you have this one beaker, right? You just one in the color palette, you have spaces, right? Would you put colors into it, uh, but if you want to add some water, something, yeah. So you take a beaker and you filled it with the water, right? Fill it with water. Then what do is you just put a little drop of this color, right? So what happens is that the yeah, so what happens is the droplet slowly mix up with it. Like you don't mix it up, just do this experiment now. After this class, yeah, you do this experiment. So what you have to do is you take a beaker and fill it with water, right? You just put a droplet of color in the beaker, and what you will recognize is, you have to comment me down what do you like observe in the beaker that you would observe. I tell you, you would observe the going down of droplet into the water and mixing in different different locations, like different location, like going some of the ink droplet is going here and some here and going down, like these go down but from different directions. Yeah, commenting down your observation, what did you observe? Yeah, both potassium permanganate crystal and water are made up of tiny particles, you know very well. When the potassium permanganate crystal is put in water, the purple colored particles of potassium permanganate spread throughout the water, making the whole water look purple, right? So what do you observe from this? This is the same as a salt and water, sugar and water, and the ink or the paint and water. You can take any liquid except water. You can take any liquid, it would mix it, but it should be yeah. Now we have actually on dissolving the particles of potassium permanganate get into the spaces between the particles of water. So what do you get from this? You basically the main perspective is to show that when we mix up when we go into the diffusion, right, when we look into the diffusion or like diffuse something, what do we observe is that the other thing or the second thing that we are gonna mix into the first thing, that's gonna be like that will go into the spaces present between this first object. You didn't get? Yeah, I'll make you understand, right? Yeah, so when we take a beaker and suppose these words are uh, water, right? Suppose these words are water and this is a full beaker, right? This is beaker, so you see that some spaces are bit present, right? So what do we observe is some spaces are present between. So let's take up like this is potassium permanganate. Suppose this is potassium permanganate going down. So how will it enter? It will enter like this, some coming from this and like from the spaces. These are the components H2O stuck with each other, right? You know very well. So these will enter like this, yeah, coming from this direction, like this and this, and by this they will cover the whole beaker with potassium permanganate. They will like dissolve into the water. This is what we call dissolving. Now also you didn't get, I explain you more time. I suppose we have a beaker. My drawing is not much good. Yeah, it is good, but not in like, yeah. So and it is filled with water, right? Suppose we have a beaker here. Sorry for disturbing much time. Yeah, and when let's and in the beaker we have water components H2O stuck, two hydrogen stuck with the oxygen, right? You know very well. Yeah, so what happens is these are the components like flowing from one direction to other, right? So what happens is when we like when we some potassium permanganate, it will go like this. It will cover all the directions. It might cover, but yeah, it covers. Yeah, it will go in this direction also, this direction also. This is what we call dissolving. This will like from every direction it would come, and lastly it would reach the bottom. This is the way how it like occurs. If something reaction is to be taken, that will mix with it and form something, whatever it wants, right? Understood? Thank you. Now we have mixing of two gases. So how do we mix up two gases? Do we make them dissolve or stir with something, right? Yeah, so let's. Fragrance of an incense stick lighted in one corner of the room spreads in the whole room quickly. Like if you lit up yeah, if you lit a incense stick in one corner of the room, like suppose it's a room, right? It's a room, and if I lit here incense stick, so what would happen? The the particles, or the the what fragrance fragrance would split into the whole room. Why? Tell me why. Comment me down. Why like spreading? Why it's spreading? It doesn't mean to spread. You also have learned, like you have also seen when your mother or you yourself like pray to God, you lit a lamp before God, and like lit a incense stick also. What does happen? What happens actually? Yeah, I tell you. The particles of gases produced by burning in the incense stick move rapidly in all directions and mix with the moving particles of air in the room. Yeah. Why does it so? I mean, why it is? So, that these shows, yeah, what happens is basically when we have a room and we have a incense stick over here, and if incense stick also spreads because there is air present here also, everywhere the air is present. I do it more time. Let's take up, this is one room, and this is the incense stick I have lit up here in the one corner of the room, and this is air. These are air particles moving all around, right? So what would happen is when I lit it up, what would happen that the fragrance, or yeah, the smoke would, let's take this one as a smoke, this color as smoke. Yeah, so what would happen, that the smoke would mix up with these particles and would pass, like the same one, right? This would pass through them and would reach every corner of the room, like it reaches like this, and it would like go every corner, and yeah, like this, you see. Yeah, so it is only because of the spaces present between the air, right? Yeah, so we have now Brownian motion of particles. Brownian motion of particles by Robert Brown. So we have here that the random or zigzag movement of microscopic particles in a fluid as a result of continuous bombardment from molecules to its of surrounding medium is known as Brownian motion. So what happens is the random or zigzag movement of microscopic particles. Yeah, you just take a look at the example, then I'll make you understand the statement. Yeah, I know it's difficult, quite difficult. Yeah, example is dust moves randomly because the random moving particles of air collide with dust particles. Suppose, let us make it understand by, yeah, these are, suppose this is a room and air particles are moving, right? And so sorry, this is a room and particles are moving, and here comes the dust would collide with it and would reach like this. Yeah, it would like flow whatever. So you might have seen your maid asking you to switch off the fan because she's brooming, right? Your maid must have asked you that switch off the fan because she's brooming. Why did she do so? Maybe she doesn't know the reason, but we should know that the dust particles would collide with the air particles, and then they would spread it every corner, every place in the room, right? So when they collide with so dust sorry yeah so dust would collide with air particles, and they would move randomly in the room, every corner, like on the bed also. Yeah, so now we have a basic of classification of matter, right? So we have a based upon particles arrangement, based upon energy of particles, based upon distance between particles. Yeah, so we have three states of matter. So three states of matter are solid, liquid, gas. So what is solid, what is liquid, what is gas? You know very well. Solid is like what? Solid is like your table, your chair. Liquid is like water, the best example. Gas is like the air that is going on around. When you like flow your hand, you feel the air, right? But you can't see how where is the air. You can't see. So by this, what do you get, right? So this is a solid box or a cube, right? Yeah, it is a cube. It is a cube over here, and in this cube the particles are tightly packed so that nothing would move. No particle would move from its original place. And in liquids, the particles are spread, so somewhat loosely packed, and so these can move, but together they would move, right? These can move freely, they can move, right? So that's why water is like flowing, because particles are not tightly packed, these are loosely packed. Next we have gases. So gases in the state, the gases move wherever it would find the place. If you close your hand, you can't see the gas over here, because particles are not tightly tied, so they are like not packed even tightly, then they are not even packed. Okay, next we have here solids and liquids. Yeah, it is that. Solid. So what is solid here? Constituent particles are very closely packed. Tightly and closely packed. If they not be tightly packed, they would obviously be close. If they are closely packed, they would be tightly packed. These are linked with each other. And constituent particles are less closely packed. Not like they are free movable, but not much, right? They are not much, but yeah, less tightly packed. Yeah, next we have force of attraction between particle is very strong, like that's why these are closely packed. When force of attraction, like you see the magnet, let's take an example of magnet, and let's take this is one magnet, and it is the north pole here, and this one is the south pole here. So they would attract each other or repel. Comment me down. Yeah, so they would attract with each other, and what would happen? North pole would, let's take this magnet as one component of solid. Let's take it as one component of solid, one component S1 and S2. Okay, so I'm so sorry. Let's take this. Let's take one magnet over here, right? And I would name them as S1, S2, so solids component 1, component 2, and let's so what would happen is the that as you know that the magnets would attract each other. So what would happen, like a magnet, when magnet north pole and south pole attract each other, like this also they would attract each other. And what would happen, what would happen is that they would attract each other and they would like stuck with each other, right? They would stick with each other like this. So by this activity you understand that solid particles are tightly packed because they have the more force of attraction. So you cannot see one component of your table moving out and like freely enjoying the air, right? You can't see this. Yeah, next we have force force of attraction between particle is less strong. So what do we recognize from this, that force of attraction between particles is less strong. That's why they can move freely, not much freely, but yeah, freely. Less than solids, no, more than solids, less than gases. Yeah, force of attraction between particles is very strong. This is the same one. Yeah, kinetic energy between particles is more than in solids. So what is kinetic energy? Comment me down, and this is basically related to kinetic energy. You have to comment me down what is kinetic energy and what do you get from this statement. You can like screenshot this one and you would understand this statement. You have to make me understand first, right? Yeah. So next we have definite shape and volume. Volume is the capacity, right? And do not have a definite shape but definite volume, right? Shape. Yeah, I have high yeah, we have high density and cannot be diffused. This cannot be diffused with anything, like you can't diffuse it with solids because the particles are tightly packed. They would not let the components mix with each other. Even solids cannot mix or diffuse with each other. Density is lower than solids and can diffuse. You know very well that we mixed up or we diffused sugar with liquids. These are incompressible, almost incompressible. We can't compress it to in extent, right? When we put a solid in a like a beaker, let's take a box, and you would keep in a beaker of size of it, right? So when you press it up, it would not compress it, either it would break or like yeah, it was obviously it would break down. Yeah, and if you take a liquid with it, maybe it would flow out or like it would not be compressible. So so about gas I'm telling you, it's not written there, sorry. Gas. So what is gas? What do you understand by gas? Gas is basically, let's understand by this only. In this particles are not packed. In this particles are not packed even. Tightly तो जब होंगे, they are not packed even. Yeah, the force of attraction is not much, is not there, and kinetic energy, yeah, very high. No, and this you have to tell. You have to tell me if I'll tell you. This would not be on you. You have to tell this statement to me, and I would let you know what is it after. In next video I would take name of who has told me the right or correct meaning. Yeah, but yeah, so gases do not have shape, volume and mass. They do not have anything. Sorry, has mass but do not have but they don't have shape and volume. Yeah, and the gaseous state or gases can diffuse, right? So these are compressible. Gases are compressible. Gases are compressible. Gases are compressible. Okay, fine. Yeah, gases are compressible. So thank you for watching this video. If you like this video, please like, comment and share this video to have whoever who needs it, or to everyone or your friends that didn't get this topic in school or wanna understand this topic more closely, right? So thank you so much for watching this video.